Hello, 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 hello. Okay, so good morning, folks. Today I have a different agenda, you can say. So today, what I am planning is I would like to have some deep dives about the hooks that I am using. For example, this use state, this use effect, and I have used use context and use ref. So while I do streaming, I am also building an applications side by side. So I have knowledge of what I'm doing in React. So let's directly jump into it. Let's see. I wonder if I have to create an application here. Let me just quickly we can create later. Okay, so let me read along this use state. Use state is a React that lets you add state variable to your component. And what do you mean by state component? Sorry, state variables. Is this on state, set state, use state, initial state. Okay, so it's open. Let's say npm create with at latest. Inside I have let's say x8. And I think I would like to work in React, simple JavaScript. Yep, EXP means experiment if somebody is watching this. Ah, okay. Mm, let's see. While it's ready, let's directly jump into the code. This is my main JSX. This is my app JSX, where my all the components will be there. And let me create another terminal just for it. Okay. Reference: use state, initial state. This one. Set functions like set something next state. What does this mean? The set function written by useState lets you, while we read this, let me clear few of the things. Okay, the set functions written by useState, this function, setter function, like set something next state. The set functions written by useState lets you update the state to a different value and trigger a re-render. You can pass the next state directly or a function that calculates it from the previous state. So here what they have done, I am setting the initial value of this name variable, state variable, to Edward, and inside my handle click function I am updating the set name function like this setter function to Taylor, and I'm again updating the age variable to increment 1. Usage: adding state to a component. Let's say caveats. Reference: I have this. Use state, initial state. Call use state at the top level of your component to declare a state variables. So these are my state variables, just like this. The convention is to name state variables like something, set something using array destructuring. Okay, destructuring assignment. So let me quickly add this into my to-do list that I generally prefer. Hmm, okay, so inside this destructuring assignment, the two most used data structure in JavaScript are object and array. Yep, or because we are mutating, or you can say manipulating the data inside object and arrays. I think the base of JavaScript can be called like object. There is even in how many like you have deep downs, you will always find playing with like key and value pairs. Object allow us to create a single entity that stores data items by key. Arrays allows us to gather data items into an ordered list. However, when we pass this function, we may not need all of it. The function might only require certain elements or properties. So inside this is how we restructure. Well, anyway, let's move on. UseState returns an array with an exactly two items. The current state of the state variable initially set to the initial state you provided. The setter function that lets you change it to any other value in response to interaction. Okay, this is my current state. This is the setter function that can update this current state, and this is my initial value for that state. To update what's on the screen, call the set function with some next state. So inside my handle click function, I am calling the set name function with the next state. React will store the next state, render your component again with the new values and update the UI. Here they didn't mention like where will this next state will be stored. Oh man, these pop-ups are really annoying. Okay, pitfall. Calling the set function does not change the current state in the already executing code. Finally, console log name still Taylor. It only affects what use state will return starting from the next render. Okay, so this is I have the state but logging gives me the old value. This is because state behaves like a snapshot. State as a snapshot. Let's go like this in a chain manner. First, let's see what is this article about state as a snapshot. State variables might look like regular JavaScript variables that you can read and write to. However, state behaves more like a snapshot. Setting it does not change the state variable you already have, but instead triggers a re-render. You will learn how setting state triggers re-render, when and how state updates, why state does not update immediately after you set it, how event handlers access a snapshot of the state. Setting state triggers renders. You might think of your user interface as changing directly in response to the user event like a click. In React, it works a little differently from this mental model on the previous page. You saw that setting state request a re-render from React. This means that for an interface to react to the event, you need to update the state. So in this example, when you press send, set is sent to true, tells React to re-render the UI. Okay, let's do this. So inside my okay, why don't we play with this a little? I can use code sandbox IO, but let's see if I can do this quickly. Inside my app, just reload it again, and I would like to here do console log message. So when I click on send, it will give me hi and render this H1 if it's sent through. So here what I want to do is let's say inside this, I do like to do this, but let's say I have is sent set is sent use state initial value is false and the default value for message is high. And here I have a condition that if is sent is true, then and only then do this. And what I'm doing is returning this form. Inside this, I have an on submit event. In that, if 24 set is sent to true, send message to the message, and I have a text area which says message value set message to e.target.value, and if possible, I would like to I would like to give them a message. This one. Okay, so let's reload this again. And in my text area, I have a button on change in which I'm setting the message function to whatever the value inside this text box. So let's do this and send. Okay, let's move on. Here is what happens when you click the button. The on submit event handlers executes. Is event to true, sets is sent variable to true, and creates a new render. React re-renders the component according to the new is sent value. Let's take a closer look at the relationship between state and rendering. Rendering takes a snapshot in time. Rendering render and commit. Okay. Rendering means that React is calling your component which is a function. The JSX you return from that function is like a snapshot of the UI in time. Its props, event handlers, and local variables were all calculated using its state at the time of the render. Unlike a photograph or a movie frame, the UI snapshot you return is interactive. It includes logic like event handlers that specify what happens in response to inputs. React updates the screen to match this snapshot and connects the event handlers. As a result, pressing a button will trigger the click handler from your JSX. When React re-renders a component, React calls your function again. Your function returns a new JSX snapshot. React then updates the screen to match the snapshot your function returned. Correctly numbers. So suppose React executing the function, it's calculate whatever the operation it has to do and convert into the JSX. That's what it means. Then update the down tree. So as a component's memory, state is not like a regular variable that disappears after your function returns. State actually lives in React itself as if on a shelf outside of your function. When React calls your component, it gives you a snapshot of the state for that particular render. Your component returns a snapshot of the UI with a fresh set of props and event handlers in JSX, all calculated using the state values from that render. So you tell React to update the state by calling that state is set is state. React updates the state value. React passes a snapshot of the state value into the component. Here is a little experiment to show you how this works. In this example, you might expect that clicking the plus 3 button would increment the counter 3 times because it calls set number plus 1 3 times. See what happens when you click plus 3 buttons. 1. Import useState. I'm importing the useState hook from the React. I have a function called counter in which I have declared the set variables called number and setter function called set number, and their initial value is 0. So let me reload this again. So inside the return, what I'm doing is I'm just giving it a number that is my initial value, and I have side by side a button in which I am calling the onClick method, and inside that I am calling the set number 3 times. And generally what I am expecting is this, that this will be called 3 times, but it doesn't work like that. So just like we see inside this, whenever I am clicking, so instead of incrementally it should be display 3 here, but it is only increment only one time. Notice that number only increments once per click. Yep. Setting state only change it for the next render. During the first render, number was 0. Exactly. This is why in that render's on click handler, the value of number is still 0 even after set number plus 1 was called. So what I'm understanding is correctly, when the button is clicked in the on click event handler, the first set number is called in for execution and it actually increment the number. But the exact uh, reflection of that increment on the UI on will only happen when the next render occurs. So these are for this the number is still a 0. Here is what this buttons click handler tells React to do. Set number plus 1. Number is 0, so set number 0 plus 1. React pays to change number to 1 on the next render. 0. Re-express number to 1 on the next render. Okay. Even though you called set number plus 1 three times, in this renders event handler number is always 0. So you set the state to 1 three times. This is why after your event handler finishes, React re-renders the component with a number equal to 1 rather than 3. You can also visualize this by mentally substituting state variables with their values in your code. Since the number state variable is 0 for this render, its event handler looks like this. Okay, for the next render, number is 1. So that render's click handler looks like this. That is why clicking the button again will set the counter to 2, then to 3 on the next click, and so on. State over time. Well, that was fun. Try to guess what clicking this button will alert. I just clicked it and it gave me the. Okay, so let's see what I am getting is the previous state. Let's see when I reload this. So currently the state is 0. So it will display the previous state. But when I actually click the button, it prepared that in my next render, it will display the number as 5, which is this. If you use the substitution method from before, you can guess that the alert shows 0. But what if you put a timer on the alert so it only fires after the component re-rendered? Would it say 0 or 5? Have a guess. I let's see. I am delaying the alert to 3 seconds. So my next render should be called 5. It's still 0. Okay, this is interesting. So let me go through this. So inside my button, what I'm updating is state. Then inside set timeout, I am awaiting for 3 seconds, and then alerting the number. Surprise, definitely. If you use the substitution method, you can see the snapshot of the state passed to the alert. The state stored in React may have changed by the time the alert runs, but it was scheduled using a snapshot of the state at the time the user interacted with it. A state variable's value never changes within a render, even if its event handler's code is asynchronous. Inside that render's on click, the value of number continues to be 0 even after set number plus 5 was called. Its value was fixed when React took the snapshot of the UI by calling your component. Here is an example of how that makes your event handlers less prone to timing mistake. Below is a form that sends a message with 5-second delay. Imagine this scenario. You press the send button, sending hello to Elise. Before the 5-second delay ends, you change the value to fill to Bob. Would you expect the alert to display? Would it display you said hello to Alice, or would it say you said hello to Bob? Like, I guess based on what you know and then fight. So let me go through this again. So what I know so far is that during the setting the state variable, like when calling the settle function, inside the snapshot, the even if my code is asynchronous or like super clean, it will still have the snapshot state. So if I go by that method, then it should display Alice. Let's click this, and if I change it to Bob, okay, it displayed Alice. You press this and before the 5-second delay and switching the value to 4. Okay, so let's again do this. I have clicked the button. Now I will say Bob, and I can click the button. It said Alice, then it said Bob. React keeps the state values fixed within one render's event handlers. You don't need to worry whether the state has changed while the code is running. But what if you wanted to read the latest state before a re-render? You will want to use a state updater function covered on the next page. Recap of what we learned. Setting state requests a new render. React stores state outside of your component as if on a shelf. When you call useState, React gives you a snapshot of the state for that render. Variables and event handlers don't survive re-renders. Every render has its own event handlers. Every render and a function inside it will always see the snapshot of the state React gives render. You can eventually substitute state in. Think about the render J6. Try out some of the challenges. Here is a crosswalk light component that toggles when the button is pressed to walk. Change to state. Change to walk. Add an alert to the click handler when the light is green and says walk. The button should say stop is next. So inside this, they want me to alert is next. When the light is red and says stop, clicking the button should say walk is next. So basically, a conditional rendering. So, so walk. What I would like to do is if walk is true, stop is next. And if walk is false, walk is next. And all of this inside alert, inside alert. Actually, it should be like this. Hmm. Basically, actually, I'm doing it conditionally alert. Okay, so when I click on, it should say stop is next. When I click, walk is next. Add an alert. Does it make difference whether you put the alert before or after the set walk call? Uh, I don't know. I haven't tried it. Let me do this and reload it again. Stop is next. Walk is next. Okay. So as I said, it doesn't make any. As I see, it doesn't make any difference. If I put this my conditional rendering uh of the alert before and after, I have seen. So so what I understand is this: it doesn't make any difference. If you ask me why, then the only answer I can arrive is that it all depends on this walk initial state variable. because as it's stated here, their initial value will always be true. So this will, when clicking, this will be called true, so it will be this. And it also like that snapshot concept. So this will it will the walk will be calculated and display on that basis. So after the the rendering, then it will change this walk to opposite of what is their initial value. If it's true, then it will convert it to false, something like that. Yeah, definitely. Let's see one on one. Okay, okay, I read it. Let's let me have a water break. Okay, so let's see. Updating state request another render with the new state value, but does not affect the count. JavaScript variable in your already running event handler. If you need to use the next state, you can save it in a variable before passing it to the set function. So something like this. Next count. I have updated the state, but the screen doesn't update. Okay, I understood what it was trying to say, that when console logging name varieties are displayed Taylor still, even if we are setting the name to Robin, it only affects starting from the next render. Oh man, actually I would like to do few of this thing. Inside that recap, so can you briefly tell me what this page try to teach us, and that knowledge, and turn that core knowledge into Anki flashcard so I can use them inside my Anki. Okay, this will be looks good. Uh, Let me quickly open this. Here is the essence of what this state of as a snapshot page is teaching, distilled onto concise points and then converted into Anki. Okay, core idea is that React state is not a regular variable; it's a snapshot in time for each render. Okay, um, there is now one thing I would like to purchase is another monitor. So I don't want you guys to see this for better or worse. Let's see. Okay, so the core idea is that React state is not regular variable, it's snapshot, it's time for each render. Setting state doesn't instantly change the variable, it requires a re-render. Each render has its own event handler and props tied to the state snapshot of that render. Multiple set state calls in whenever use the same snapshot value so they don't accumulate. Event handler always see the state from the render in which they were created, even with asynchronous code like set timeout. React stores state outside the component function and passes the snapshot back in during each render. To access the latest state across renders, you need to update functions covered in the next section. Okay, got it. Um, let's add this one by one. In React, what happens when you call a state setter like set is sent to true? It quiz a re-render. The state variable itself doesn't change immediately. Why is React state described as a snapshot? Because each render captures the state at that moment and event handlers props are tied to that snapshot. Okay, what happens if you call set number plus one three times in the same render? The state only updates once because all three calls use the same snapshot value. How does React how does React store state compared to local variables? State lives in React itself outside the component function and is passed back in during each render. Why does alert number inside a set timeout show the old value? Because the event handler uses the snapshot from the render when it was created, not the updated state. Do event handlers survive across renders? No. Each render creates new event handler bound to that render's snapshot of state. How can you read the latest state value before a re-render? By using a state updater function which React provides as an alternative to direct setters. Would you like to expand this into a larger tech, covering the example like cluster counter, delayed alerts, and traffic light challenge? Nah, even it's fine. Uh, okay, this one strong information from previous trainer. Okay. Inside this, I think they were telling me something. This is his strategy, so I guess it's not. Hmm. Basic use state example counter number. In this example, the count state variable holds a number. Clicking the button increments it. It raised to one. Okay, one. So let's see if I have here my count displayed, and I would like to have one button in which I would like to have another handle click, handle decrement, decrement, Inside it, I will have this. Here, I will have this. And let's do this semantically. Ah, inside handle. Okay. Da-da-da-da, da-da-da-da. That's negative. Okay. Next example. Example 2 of 4 text field string. You type hello. Say if you type John Doe, if I click on reset, it will set text to empty. Okay, so here setting text to hello, but I would like to have an empty. When I click this, it is empty. And when I click here something, it should display. Okay, it's working, it's fine. Let me go to the next state. In this example, the like state variable holds a boolean. When you click the input, set like updates the like state variable. hmm Check the like initial is false, right? Oh, okay. Set is like did not like. Next, you can declare more than one state variable in the same component. Each state variable is completely independent. So let's say increment age. Hey, Bob. Okay, moving on to the next. Updating state based on the previous state. Suppose the age is 42. This handler calls set age plus 1 three times. But let's say it's still gonna be like update only one time as we saw. Yeah. Calling the set function does not update the age state variable in the already running code. So it stays becomes set age 43. To solve this problem, you may pass an updater function to set age instead of the next state. Now this is cool stuff. So this takes the initial, which is 42, update it. Now the what is the last is state, which is 43. Okay, pending state and calculate the next state from it. React puts your updater function in a queue. See, being a series of state updates. Okay, I just read this. I guess it's fine if I can skip this. Yep. Then during the next render, it will call them in the same order. A is equal to plus 1 will receive 42 as the pending state and return 43 as the next state. This one, second set edge, will receive 43 as the pending state and return 44 as the next state, and so on. There are no other queue updates, so React will score 45 as the current state in that. By convention, it's common to name the pending state argument for the first letter of the state variable name, like A for age. However, you may also call it like previous age or something else that you find clearer. React may call your updaters twice in development to verify that they are pure. Updaters twice in development. My initializer update function runs twice. In strict mode, yes, this strict mode. Although I also would like to learn more about the strict mode, but we- let's quickly go through. React will call some of your function twice instead of once. So, Mhm. This is expected and should not break your code. This development only behavior helps you keep components true. Sorry. React uses the result of one of the calls and ignores the result of the other call as long as your component initializer and updater function are pure. This should not affect your logic. However, if they are accidentally impure, this helps you notice mistakes. For example, this impure updater function mutates an array in state. Leaves don't close create to do mistake mutating state, which is a red flag. So what we want to do is inside the array, we get all the previous to-dos list. Then we call the create to-do. So it updates it with the new state. What does keeping components pure mean? Let's look this through it. Okay, keeping components pure. Some JavaScript functions are pure. Pure function only perform a calculation and nothing more. By strictly only writing your components as a pure function, you can avoid an entire class of baffling bugs and unpredictable behavior as your code base grows. Get these benefits, though there are few rules you must follow. You will learn what purity is and how it helps you avoid bugs. Blah blah blah. Purity, components as formulas. In computer science and especially in the world of functional programming, a pure function is a function with the following characteristics. It it minds its own business. It does not change any objects or variables that existed before it was called. Same inputs, same output. Given the same inputs, a pure function should always return the same result. You might already be familiar with one of the example of pure function formulas in math, like consider this math formula y is equal to 2x. If x is equal to 2, then y will become 4. Always. Oh, if x is equal to 3, y will then sometimes be 9 or dash 1 or 5, depending on the time of the day of the state of the stock market. If we made this into JavaScript function, it would look like this, definitely. In the above example, React is designed around this concept. React assumes that every component you write is a pure function. This means that React components you write must always return the same JSX given the same inputs. When you pass drinkers to recipe, it will return JSX containing 2 cups of water always. If you pass drinkers, so it would so water always, just like a math formula. You think of your component as a recipe. If you follow them and don't introduce new ingredients during the cooking process, you will get the same dish every damn time. That dish is the J6 that the component serves to react render. Side effects. unintended consequences. React's rendering process must always be pure. Components should only return their JSX and not change any objects or variable that existed before rendering. That would make them impure. How? Here is a component that breaks this rule. This component is treating and writing a guest variable declared outside of it. This means that calling this component multiple times will produce even JSX and they will produce different JSX. So depending on why when they were rendered, that's not predictable. Going back to our formula y is equal to x, now even if x is equal to 2, we cannot trust y is equal to 4, our test would fail. Our users would be baffled and plans would fall out of the sky. Planes. You can see how this would lead to confusing bugs. You can fix this component by passing guest as a drop instead. Now your component is pure as the J6 iterates only depends on the guest prop. In general, you should not expect your components to be rendered in any particular order. It doesn't matter if your call is y is equal to x before or after y is equal to 5x. Both formats will resolve independently of each other. In the same way, each component should only think for itself and not attempt to coordinate with or depend upon others during rendering. Rendering is like a school exam. Each component should calculate JSX on their own, detecting error calculation with strict mode. Although you might not have used them all yet, in React, there are three kinds of inputs that you can read while rendering: prop, state, and context. I have dealt with both like props and state, and I have seen the by using console logging their data. But and I have also used context, but only in one of the project that required me to just use create context. You should always treat these inputs as read only. When you want to change something in response to user input, you should set state instead of writing to a variable. You should never change three existing variables or objects while your component is rendering. React offers a strict mode in which it calls each component function twice during development. By calling the component functions twice, strict mode helps find components that break this rule. Notice how the original example displayed guest 2, 4, 6 instead of guest 1 to 3, right? The original function was impure, so calling it twice broke it. But the fixed jobs version works even if the function is called twice every time. Pure function only calculates, so calling them twice doesn't change anything, just like calling double. Twice doesn't change what's written, and solving y is equal to x twice doesn't change what y is. Same input, same output, always. Strict mode has no effects in the process, so it doesn't slow down the app for your user. Opt into strict mode, you can react to the root component in 30x. Some frameworks do this by default. Oh, okay. So this is my I would like to end my stream here because there are a couple of things that I would like to have a deeper dive. See, basically, I will continue from this. Okay. Well,